To begin 8.1, let's compare three different kinds of variation. The first is one that we have seen before. We won't use it in this section, but it'll be helpful to reference. So this kind of an equation or function is called direct variation. Or we would say x and y vary directly. And that's because an example of a direct variation equation would be like y equals 2x, right? This a is a constant, and as x increases, what kind of behavior will y have? It'll increase, right? We'll put a 1 in for x, and we'll get out a 2 for y, and a 2 for x, and a 4 for y. And you can see as one goes up, the other goes up. Yeah. So x directly affects y because it's multiplied by a 2. You just take x multiply it by 2, and there you go. Directly varies with y. Now, this section introduces an idea that we'll use throughout this chapter, and that would be when you have x in the denominator of a fraction. Now what happens as x increases? Let's jump down here. I'll skip the name for a second. Y equals 12 over x. Let's say that is our equation. That's our example. So what happens to y as x increases? What's the behavior there? So x, let's say x is 12. So 12 divided by 12, that's 1. Let's say x is 6. I guess we're making x decrease. But let's see what happens to y. So as when x is 12, y is 1. When x is 6, then y would be 2. If x is 3, then y would be 4. When x is 2, y would be 6. Okay, so you see, as x gets smaller, y gets bigger. So y doesn't go directly along with x. You know, x goes down and y goes up. And we could go the other way. X could go up and y would be going down. Okay, so that's why we call this inverse variation. Okay, it varies inversely with x. X varies inversely with y. Or we could say x and y vary inversely, or what have you. So that's inverse variation. And we're going to progress through the idea of inverse variation. We're going to go right into what we call rational functions here pretty quickly. And that rational functions are made by having x in the denominator of your function. Okay, so this is just a little baby intro into it. This we would call joint variation. We would say in this case, z varies jointly with x and y. Z varies jointly with x and y. Because as x and y do their thing, they're going to affect z. And it's going to be a joint kind of situation. So let's say, for example, that z equals 0.05xy. So we say that z varies directly with x and y because as x and y together increase, z is going to increase. It might be a little confusing to draw a table of values because x and y will vary, and then we'll get a value for z. So x and y can be doing different kinds of things, but the example that I like to think of is, say 0.05 is 5%, right? So let's say that you have a guy who buys your stocks. This is a job some people have. They give you advice and they buy your stocks for you. And they make money off of how much you spend on stocks. So let's say that X is the cost per stock, or per share, I should say, share of a stock, and Y is the number of shares that you buy through this person. Okay, so depending on how much you spend altogether, their money that they make goes up with the number of shares that you buy. Well, it goes up with the amount of money that you spend, right? Now, whether it's a pretty low cost per share, but a lot of shares, a high number of shares, that could cause their pay to go up, or it could be a really high cost of per share and not as many shares, and that would cause their profit to go up. So this idea of joint variation, it's, there's real world applications. It does happen. We're not going to spend a whole lot of time on it, but it is there. It is worth mentioning, and we'll do some more specific stuff in the sample problems. So thank you for watching.